My friend Michael Feathers defines legacy code as code without tests. So how do we take bad legacy code and make it testable? Hi, I'm Dave Farley and welcome to the Continuous Delivery channel. If you haven't already, please hit subscribe, and if you like the video at the end, hit like too. This is the last in a short mini-series on refactoring legacy code. If you've missed the earlier episodes, check them out. There's a link up here that you can follow. But in this episode, we're looking to move on and look at the next stage. We've already explored a four-step approach to refactoring in this context. Approval testing, removing clutter from our codes, reducing cyclomatic complexity, and composing methods. Those strategies help us organize our work, and we can kind of iterate over those as we explore the code. In this episode, we see the fruits of our work. We start adding tests and learn more about how the code works, and we fix some bugs that were existing in the code before we started. Welcome back. It's a day later and I'm looking at the refactoring the nasty code again and trying to improve it. Depending on which version of the video you've seen, we may have jumped ahead a little bit in terms of where we're at now with the code. But what I'm looking at now is really, I'm on the end game. I'm starting to look at getting to testability for this code now. I'm just going to do a quick recap of where we are with the code, and here it is. So we have our top level public getJSON method, which, if you remember from last time, I refactored a bit so that I could inject a document into it, and I pulled out a second method which is called getJSON for doc, and that's composed so that we're initially figuring out our starting point in the structure of the XML that's supplied. Iterating over the elements in that XML, and then closing off the JSON document. So we've reduced the complexity of that method significantly, and we've kind of composed the method so it tells its own story a little bit more clearly about what's going on. So hopefully now, if you read this method, it's easy to understand what's going on straight away. I'd made some other significant steps, at least to my mind. I've pulled out some new classes, a folder element and a document element class. These were obviously places where there were differences depending on the nature of the elements that we've been parsed, and I've pulled those out so that we can kind of separate those and think of them as independent items. This in itself is a significant step towards testability. So we have an abstract interface which just says process element and takes some arguments, and then we can, if I can step back, where have I gone? There. And then two implementations of that at the moment, a folder element and a document element. Those are the two different kinds of elements that we found that the code was attempting to parse. So here the top level method is process element, and again I've done a little bit of this refactoring, so I've tried to compose that a little bit. We've got some stuff that's pulled out here. There's still more work to do here. There's still more tidying up to do here, but it's a little bit more organized. This method here, process folder attributes, slightly more complex than I would like. It's got a for loop and if conditions. I'm probably going to sort something out to simplify those. But already this is starting to look like a thing that's a bit more testable. We've got one entry point, and it's clear what this is trying to do. It's trying to take this stuff and then get and generate a string out of it. So can you imagine writing some tests around that kind of thing? And we probably will. And we've got a little array to do those. I could probably tidy up the code a little bit further to move these into a better state. This is left in the middle of where I was working. So let's start there. So now the actual code that's doing the work is relatively straightforward. As I said before, we've got the get JSON for doc and close JSON process element, which is going to use the elements from that hash map, looking it up by the type of element. Depending on the type, it will get the appropriate parser, and then invoking that parser to do the actual parsing of the content of that element. I tend to start test cases with the word should. This is a BDD trick, an old school BDD trick. The idea is if you start a sentence in English with the word should, it kind of puts your mind into a mental state where it's hard not to think of a descriptive behavior specification for what it is that you're trying to achieve. So in this case, should parse simple doc element. So we could imagine a test that was something like that. So what do we need in order to be able to do that? So we're going to need a copy of our class that's under test, and we're going to populate that. So we're going to XML to JSON, and we're going to translate. Our test is going to do something like, we're going to do get JSON for doc. We're going to do that version. We're going to have a string that's got some path stuff in it. And I don't know what that looks like yet, but a simple doc element, whatever that means. And we're going to have a document. So we create a simple method called create doc in my test case. So I'm going to have a sax reader, a document, and the document's going to, I'll just throw them out. I'm not very interested in that. And I'm going to do that with, so let's pass a string into here that represents my doc. And we'll do a, what kind of input string can I do? Okay, so we can create a byte array input stream. We can read that. I think that's just complaining about throwing in a method. That's okay. So we can just throw up the exception. We can get the document. So we can just return the document. So we can just return that. So that looks like something that we can do. So now we can generate on the fly in the space of my test, just on the basis of strings, some little documents to test. Okay, so that looks like we got a different error. So now we're expecting something, but was something else. Create a document that's searching. So let's go and see what's going on as we walk through there. It's not found any elements. That's why I've got just an empty string. That looks like a mistake though. We were opening the string and closing the string. So what are we actually returning there? It said expecting nothing but got a single closing brace. and I think we expected an opening brace as well. That was a bug in the original code. So I'm going to fix this bug. Why is it doing that? JSON string substring 0, JSON string length -1. I don't understand why it's doing that. It looks to me as though it ought to just do that, and that should give me... That looks to me more like what I want, so I really don't think that that's doing anything. They might be worrying about some case that I'm not thinking of right now. I'm going to temporarily leave that commented out. I don't like leaving commented out code in my code. It's a bad habit because I'm going to forget about that and forget to come back to it. So I need to be disciplined and be sure that I'm coming back to this soon. But I'm going to leave that there for now. But I think what I've just done is fixed a bug. So now I've got a difficult decision. Should I make the code work, or should I keep it the same as it was before? Given where we are, I think that I'm in favour of making this code work. I'm taking a risk there. It's possible, but if this was, I would probably not be doing this if the code was more complicated than is going on here. But this is a difficult decision that you will often face when refactoring real legacy code. Doing this kind of work, pretty likely you're going to find some bugs. That's a good thing on the whole, but if this was real legacy code of thousands or tens of thousands or maybe even millions of lines of code, it's quite probable that you don't know whether you should fix those bugs or not. And then it's a difficult decision. It's difficult to make. You've got to then go, this is more of an organizational problem than a technical problem. You know what the problem is. You probably know how to fix the bug, as I do here. But should you fix the bug and what the implications of that on other areas of the code? Very, very difficult to tell. You're going to have to understand it in the context now and take that, probably to a wider audience, have a conversation with this about other people and decide how you're going to proceed. I have certainly in the past worked in environments where we were required to keep the code failing in the same way that it always had. That's an odd decision to make, but it's the reality of these sorts of situations sometimes. So we've got our test. We've got our test. Our new test is now failing in the way in which nearly in the way in which we anticipate. It's not quite giving the message that it's not returning any value, so it's not actually finding anything in that search. So at the point at which it's getting a node, that node doesn't have any elements in. So I don't know whether, I think it might be just because, I'm almost certain that it's the way in which I've set this up. So let's do something that's just a little bit closer to the original, which is it was organized around an enclosing folder. So let's put our doc element inside an enclosing folder. Let's just try that. Remember, what I'm trying to do is that I am trying to be genuinely minimal in the amount of in my test case, and so I'm trying to keep it as simple as I can get away with to make this work. So a folder containing a doc with a title so let's run that. And what I'm aiming for, I'm trying to get to a failure where it's saying the string that's contained, which hopefully is involving something to do with my document and my title, is returned in a JSON format somehow. So let's run that and see what happens now. Now we've got something, look. Aha! Now we can also see why why that earlier line of code that I commented out was required. It was trying to remove this trailing comma. So it was doing it. So this is interesting, because what we've done by going through this test is that we're starting to find ways in which the behavior of the code is not fit for purpose. There were special cases. There were cases where this code failed. It gave JSON that was invalid JSON. A closing square bracket is not valid JSON. And so we wanted in that case, it should return an empty string. So that's a good test. So why don't we create that test? We've got a little bit of infrastructure now. So we've learned a lesson. Let's add that test so we have an even simpler test, and we know what we want now. So should parse simple should empty document. So we're going to have an empty document. We're going to give it nothing useful. So we'll have a folder. That's our top level document. No document inside. Now when I run this, what I want is that I want valid empty JSON. I want empty JSON as the result of this test. So let's run that test and see what happens. My test passes, but it passes at the expense of this because this one fails. Now I've got two tests that define the behavior that I'm looking for. If the document is empty, I want to give valid empty JSON, and if it contains some valid useful value, then I can return that correctly. So now we've got something that we can work with. We can now use the test as a tool to give us the answers that we want. So we know what our expected outcome is. So let's run that again. We'll just run that. In strict test-driven development terms, I am cheating now because I'm looking at the output of the code and I'm taking the output of the code as the value that I want. You've got to be very careful when you do that. This is not how you do test-driven development when you are starting from scratch with new code. But I'm not there. I'm working with code that I don't completely understand, don't understand all of the implications with, and so I'm being a little bit more pragmatic and a bit less pure in my application of these techniques. So here's my string, and that's wrong. That's not the string that I want. That is the string that I want, I think. Probably without that trailing comment, that trailing comma too. So I think that's what I'm really looking for. I'm looking for the data element with the title. That looks good. That looks what I'm looking for. That looks like it's sensible. It looks like what I'm after. And it's definitely going to fail when I run this because of the extra commas. So let's now go back to our piece of code. So this was what the original code was doing. It's broken, but this is what the original code was doing. So if we run our test now, what happens? Still failed, but we lost our trailing comma here. So I think we got two bugs. I think we've got a different bug here. So we'll tackle that. But it fixed this bug of the trailing comma after the curly brace. But we've also now broken our other test. If you recall, broken our null test. So let's see if we can fix those two to that level. I'm going to cheat a little bit, just as a way of making some progress, and only temporarily. So I'm going to put this comma back in, and I'm going to run my test. Now we must remember that I've got to keep honest. So that didn't do what I thought. I put it in the wrong place, that's why. There, that's what I wanted. So, right, so that gives me a passing test, and I'm just going to use that for a moment while I look at solving, getting this part of the code working. correctly so that it passes my 2 tests as they stand, and then I'm going to revert to the failing test to fix the other bug, the second bug. So here what we're looking for is that we want to preserve the JSON strings. So maybe the simple thing to do is okay, so I think that gives me my that's that test passed. Let's check that the other one still passes. So I'm going to run all of my tests again, and yes, we're all passing. Good. So we've fixed a bug. Now we need to go back and be honest. Remember, I cheated by adding that in. That's not really what I want. I want that. I want it without the comma. So now that test is going to fail. So if I run all of my tests, yeah, that test failed. The others passed. So now I can start digging in and finding out why that one's not working correctly. So let's see what's going on. We should have one test failed, which is the one with the comma in the wrong place, which is correct. So now I can remove the trailing comma here, I think. So let's do it neatly. Remove trailing comma. Let's say what we're doing. JSON string equals create a method JSON string. Okay, so we can now do whatever we want. So the simple thing to do is to return that, and that's going to keep everything passing. That's a behavior preserving change. It's keeping the one test failing. So now let's try and make that test pass. So we could be cautious. We could say if JSON string dot ends with comma JSON string equals JSON string dot substring 0, comma JSON string dot length -1. So if the string ends with a comma, I'm going to truncate the string. I'm going to shorten it by 1 character, the comma, and return that. Does that make our test pass? Yes. So there's a lot more that we could do with this code. There's a lot more that we could improve, but let's stop there. Let's recap. We've improved the code to the point where we could start writing tests, and we've written a couple of simple tests. Even at this level, as soon as we did that, we started to see bugs. We started to find out how the code worked and how it didn't. They gave us deeper insight to the code. Now, I didn't plan this ahead of time. I didn't look into the code before I started this exercise and think, we're going to get here and we're going to find this weird hanging comma and that's going to be a problem. We discovered that. You saw me discover that in the video as we explored. However, I wasn't really surprised. In my experience, every single time that I've carried out this kind of approach in real legacy code bases, I find similar kinds of things. And this is why the techniques are so valuable. Using tests as a means to explore the code, we gained new insight, we fixed bugs, and learned what new tests to write next. Refactoring isn't about making changes for the sake of change. Refactoring is a tool that in the real world we use to target where we want to do useful work. It's rather like tidying your workbench before you start work. Refactoring allows us to clear the field in the area where we're going to do work so that the work that we do is then better and higher quality. Refactoring allows us to better understand where to start and what to do. This should make it safer to make changes, not more risky. Inevitably, in this exercise, it was a little artificial. I chose some nasty code, but it was a relatively small piece of code. I recognise that, but I hope that it has demonstrated some of the thinking and the techniques behind the strategy that I tend to employ in these real-world situations. Thank you very much for watching.